what you're seeing is a computer screen. There's an interface box here with a computer screen and a temperature probe here. The temperature probe is sitting down in some water. I've set the screen up to monitor what's going on with the temperature probe. So I'm going to begin the experiment and begin observing some temperatures. Now this procedure will actually go on for about 10 minutes. I'm going to put just a minuscule amount of cold water in here. And I'm going to insert a thermometer, or the thermal probe, temperature probe, if I can get that to stay there. And what we want to do is watch how the temperature changes. Maybe I'll be better off putting it like this and getting out of the way. I'm having some trouble getting this to hold still, so I'm going to have to kind of hold it here. Maybe. There, it's holding still. Now we see the temperature of the water sample rising toward room temperature. And that temperature is going to rise along a sort of a steady curve as we come up to room temperature. We're going to watch that for a few minutes. We're going to pause. Well, let's not pause. Let's go ahead and watch this thing. Okay, temperature is rising toward room temperature. Now just to see what's going to happen to speed things up, I'm going to take the thermal probe out of here, dry it off, and watch how the temperature comes up much more rapidly this time. And we're going to focus on the screen a little more closely. We see two parts to the curve. On this part, the temperature was coming up and is actually starting to level off toward room temperature. Room temperature is around here someplace. But of course, with the water around it, the temperature wasn't changing as fast as with no water. So we're going to be able, in another minute or so, to see what the temperature curve actually looks like just for the probe. Now this isn't overly important at this point, but we're going to see how this fits in with an experiment. So now as we watch this, let's ask what would happen. Let's say that I had this temperature probe back in the water and I placed a hot sample in the water. Now we'd be along this curve, which is coming up very gradually instead of this curve. If I place a hot sample in the water and stir vigorously, that's going to cause this curve to jump a little bit, or a lot, depending on the sample and how hot the sample was when it was placed in the water. And that's the kind of thing that you're going to observe just from the graphs I gave you. Obviously you don't have this equipment at home and we can't send it to you. You wouldn't want the hassle of setting it up anyway. And you, in some cases, cannot come on campus and do this experiment, although if you wish, you're welcome to. I can set this up for you in just a few minutes, show you how to use it, and then let you run the experiment. Now the actual experiment is going to consist of leaving the thermometer in the water and placing a sample in the water. The sample has to be small enough that the water covers it. Alternatively, you have to have enough water to cover the sample. And then we're going to observe what that does to the curve and how that changes the curve. And then we're going to make some inferences. The thing you need to see is that for every temperature being measured here, there's a certain rate at which the temperature wants to go up, just because of the thermal exchanges with the room. When we did the original experiments, we didn't take account of thermal exchanges with the room. And this is going to, this information for a given amount of water is going to allow us to take the thermal exchanges with the room into account as we talk about the thermal exchanges between the sample and the water. Now we can see how the temperature of the probe is going to approach that of the room. When there's water, again, the approach is much, much slower than what you see here.